Okay, we're given that the amount of detergent dispensed into bottles of liquid laundry detergent for a particular brand is normally distributed with a mean mu is equal to 88.9 and a standard deviation of 2.1. And it says if 14 bottles are randomly chosen, so n equals 14. What's the probability that the mean, x bar, fill is greater than 90.6? Okay. Well, the first thing I want to point out is that notice it tells us it is normally distributed. So hence, I don't have to worry about the central limit theorem kicking in because I'm given that this is a normally distributed distribution. So notice that my sample size does not meet the requirements of the central limit theorem kicking in because it's not greater than 30, but it doesn't have to kick in because I'm told it's normal. So let's go ahead and find the z-score for this. So recall the formula z is going to be x bar minus mu over sigma over the square root of n. 90.6 minus 88.9 over 2.1 over the square root of 14. .6 subtract 88.9, and then remember the little trick I told you, go ahead and divide by the denominator here. This is a complex fraction. Complex fraction is where you have a fraction where your numerator or your denominator also has a fraction in it. So divide by the 2.1, and then we're going to multiply by the denominator of the denominator. So times second square root of 14. So if you need a lesson in complex fractions, you may just Google that and get some more information. 3.0290. That's out there, so that probability is going to be really, really small. I'll tell you that. So let's let's change our probability statement. So the probability that x bar is greater than 90.6, the same thing as the probability that z is greater than 3.0290. Draw a curve, standard normal curve. This is positive, so it's over here. More likely over here. I'm just drawing it to, obviously not to scale. 3.0290. And we're wanting greater than. So we're wanting this area here. We know on the TI. And we'll CDF. Since this is a left endpoint, 3.0290, comma. It's positive. We're going to use their positive 999. 999. Okay. Let me clear all that. Second bars. Normal CDF. 3.029, comma 999. 0.0012. If you ever get anything in here like this is, it'll usually be a number and the decimal and another number. You'll have like an e to the negative 4 or 5. That means you take your decimal place and move it. Let's say it's e equal 4, e equal negative 4, I should say. Then that means you take your decimal place and you move it 4 places to the left. If it was e equal positive 4, that means you take your decimal place and move it 4 places to the right. Just a FYI there. So stat disk, we'll do the same thing. Analysis 3.029. Remember that it's we found this out in the last one that it actually gives me the area to the right, okay, which is nice. since it says here to the, if I had to put that value in, I have to know that value from the left, and I'm trying to find the value that corresponds to the right of 3.029. It gives me right here. So for stat disk, probability is 0.00123, which is the same thing. What are we rounding? 3 decimal places? Okay. 0.001. So that's not likely to happen. If you're thinking about this as a percent, move your decimal 2 places to the right and add a percent sign, so you are at 0.1%. Not very likely, so 0.1%. Not very likely to happen at all. But we're wanting this as a decimal. Okay, if you just take 14 randomly selected bottles and found out that they had a mean of 90.6, should the machine be recalibrated? Well, yeah, if all 14 of them had the mean of that, you added up the 14 and their mean was 90.6, that's not very likely to happen. And if you're getting that, then something is bad wrong. So, yes, that needs to be recalibrated. Let me know if you have any questions. Thanks.